Hi class. I don't have a title for this this video, but it has to do with a sort of a problem that I've seen on several AP exams, and it usually involves some kind of piecewise function like this one. So, the question is, for what values of a and b is the function differentiable at x equals 1? And you can see 1 is where these two pieces here split. Okay. Now, we're going to need to remember there's a theorem or something. I don't know. Guess it's a theorem. If f is differentiable, then f is continuous. And we're going to need that to figure out both a and b. So the idea behind this theorem and what it's saying, you think about like a set here of all continuous functions, that the ones that are differentiable are going to be a sort of a subset of that. You may not think that's what the theorem says, but it really is what the theorem says. So the idea here is if I'm a function right there and I'm differentiable, well, I'm also in the continuous circle, so I have to be continuous too. Alright, so what does it mean for the function to be continuous at 1? It means the left-hand limit and the right-hand limit have to be the same, and the limit has to exist. Well, you know, these pieces are polynomials, so they're going to be continuous, so that's not going to be a problem. But they do have to meet at 1. Alright? Now, a lot of people, what they do is they plug 1 in and they just set the two sides equal, and that's the correct thing to do. But if you want to get full credit for this problem, you're not going to do it that way. Okay? So what you're going to do is you're going to take a left-handed limit. Okay? And on the left side, that's all the x's that are less than 1. We're dealing with 2x minus 1. So this is the same as the limit as x approaches 1 from the left of 2x plus 1. I think I said minus a second ago. And we just plug 1 into that and we're going to get 3. Okay? And consequently, we take the right-sided limit of f of x, and on the right side we're dealing with ax plus b. So that's the limit as x approaches 1 from the right of ax squared plus b. And when we plug 1 into that, what do we get? We get a plus b. Okay? And if this function is going to be continuous, the left-hand limit and the right-hand limit have to equal, so that means we have the condition that a plus b has to equal 3. Okay, now let's deal with the continuity here. Now we need to deal with the differentiability. So let's do that on this other side of the paper. Okay, so if f prime exists, well, it's going to be the derivatives of the pieces. Okay, so derivative of 2x plus 1 is just 2. So 2 for x less than 1. And the derivative of ax plus b, we have to remember that a and b are constants. So the derivative of x squared is 2x. So we're going to get 2ax for x greater than 1. Now I'm not writing equal to here because we don't really know what f prime is. That's what we're trying to find out. Okay? So when x equals 1, don't know, we're going to solve that. Alright, so no big deal. Once again, we need to do a left-hand limit and a right-hand limit. So the limit as x approaches 1 from the left of f prime is the same as the limit as x approaches 1 from the left of 2, which is just 2. And limit as x approaches 1 from the right of f prime is the limit as x approaches 1 from the right of 2ax. And we plug 1 into that, we're just going to get 2a. Okay? So those have to be equal for the thing to be differentiable. So 2a has to equal 2, so that means a is 1. And when we come back to this guy, a plus b equals 3. Now plug 1 into that. 1 plus b equals 3, so b is going to be 2. B is 2, or not 2b. And that means a equals 1, and b equals 2, and there's our solution. So this is a real kind of common problem. Sometimes when you're looking at these functions, it's all about continuity, and it may be one of the removable discontinuities where it's something for x not equal to 1 and something where x equals 1, and maybe you have to figure that out. Sometimes you don't need to do left and right-handed limits, so sometimes if it's just a removable discontinuity, you don't have to do that. So these problems are all a little bit different, but just be careful. Note that the continuity does not imply differentiability, so just because the function is continuous doesn't mean it's differentiable. And I've even seen a question where the two parts here, one of them was 2x plus 1 and the other one was 2x plus 3, and they asked if it was differentiable at 1, and the answer is no. Even though both derivatives are equal to 2, it's not continuous at 1, so therefore it would not be differentiable. Alright, that's it for now. Toodles.